Welcome. In this segment, we'll talk about how to deal with digital image processing of the second segment. And in this segment, we'll be talking about three different tools that we can use for digital image processing. And they are the edge detection, pen sharpening, and also performing visual interpretation using texture analysis. So let's get right to the script. In this example, the first one I will talk about the edge detection. This is a very useful way to find the boundaries of objects within a remote sensed image. And we first start by line 7. This should not be new to you by now. This is simply just importing the image and for us to display and use for further analysis. Line 10 and 13 is simply centering the map down below to display our imported Landsat 8 image. The edge detection code starts on line 16, and you will see this new algorithm that I'm highlighting here. That is called the EE algorithms canny edge detector. This is a algorithm that can be applied to a Landsat image or any image to find the boundaries of an object. And I will show you in a second when we run this script how this result looks like. And on line 20 is where we display the result of the canny edge detector. On line 23 down below, we bring in another function. And as I'm highlighting on line 23 there, the hue transform function basically utilize a grid size over the canny edge detector result and to smooth out and have a better detection of the edge, as I will show you in a moment when we run this. And finally, on line 26 is where we display the transformed edge detection result. And why don't we just run this real quick by hitting the run on the top. And I will show you the map down below, what it looks like. So at first, there are three different layers, as you can see there. There is the input image, the canny edge detection, which is the second layer, and then also the hue transformed canny edge detection layer. So I will first show you what the input image looks like. So this is a very typical Landsat image. This was taken over the city of Syracuse. As you can see, there are different distinct features in this map, such as the Onondaga Lake up to the where my mouse, the cursor hand is pointing at. And then we apply the edge detection, which produced this canny layer. And now you'll be able to see a whole bunch of squiggly lines that were produced inside the Landsat image. And all of these are essentially using the canny edge detection algorithm to depict any boundaries between pixels that the algorithm thinks it's a boundary. And we can see sort of, not very clearly, but the lake itself has kind of very clear boundary to it. But again, there are so many lines within these boundaries of the lake. It is not very clear for the lake itself. So then we apply the hue transform. And this is an algorithm kind of picks among these lines to pick the best, most confident boundary, if you will. And it will transform this candy layer. So if I turn on this hue layer, now you'll be able to see the Onondaga Lake has a very clear boundary as opposed to the one we saw before. And another feature that kind of stands out is near the airport area, Syracuse airport area, there are very clear edges of the runway. As you can see on the screen there, it looks very standout feature. Not only the roads that leads into the runway, but also the runway themselves. The boundaries of those are very clear using this edge detection method. And if you want to further process from this, you can of course export these boundaries into shapefiles, and you can use that for detecting edges and enhance them. So that's edge detection and how you can use that. In the next example, we will quickly look at pen sharpening in HSV space. So let me just uncomment this area so we can look at it better. And we'll focus on the script in a second so I can explain what is happening. So pen sharpening is a way for images to have a higher spatial resolution. And if you are working with Landsat image, you're in luck because there is a band in the Landsat images that is much lower spatial resolution. And you can use that band to help you enhance the image resolution of the Landsat pixel of the other bands. And I will show you how that works out. But in general, the pen sharpening is the methodology behind, or the term to describe transforming an image that has larger pixels into a smaller pixel through some kind of transformations. So if we look at the example, we first start with importing the image on line 33, as we always do before to work with the image. Then we display this image through the RGB color combination on line 36, as you can see there. Then we transform the image into HSV space. As we have mentioned this in the shadow detection tutorial video, HSV stands for the hue, saturation, and value. This is a completely different color space that you can transform an image into. And the reason why we use this is because we are preparing it to be pen sharpened in further steps. And then on line 44 is where we actually utilize the band of B8, as I'm highlighting here on line 44. On line 44 is where we are selecting this spatial resolution that is smaller of band 8 to transform our other band informations. And in this way, we can see a much more clear picture of the Landsat image. And in this case, we are simply transforming the original Landsat resolution of 30 meter down to 15 meter in this case. On line 47 is where we transform from HSV space back into RGB space. So this is the function I'm highlighting there is how you can conduct such transformation. And then on line 50 is where we center our map to display the image. And then on line 53 is where the sharpened image will be shown in the map down below. So why don't we just run this also, and we'll show you the map, how it looks like. So I hit the run here, and hopefully something shows up down below in the map. Okay. So immediately you'll be able to see there are two different layers. One is the RGB image. As you can see on the screen there, this is the first image, which is the Landsat image itself. It has the 30-meter resolution. Why don't I just turn that on only and show you what that looks like? Okay. So this is the original Landsat image. Obviously, it's not very clear, especially for smaller features such as buildings, downtown, the roads, so on and so forth. And when we pen sharpen this image, we should theoretically have a smaller spatial resolution. So if I turn on this, you will see a transformation of the spatial resolution of the image, or the pixel size of the image to be exact. And if you zoom in, as you can see on the screen there, the features are much more stand out. So if I, for example, zoom to an area such as the carrier dome, which is this large white feature down here, as you can see on the screen. When we pen sharpen, it looks something like this. But in the original image, it looks very pixelated and very hard to find boundaries. So this is a way for you to pen sharpen an image and find the boundaries of a feature much more easily compared to the previous information that you have. Pen sharpening is somewhat controversial in terms of image analysis because it is manipulating what is actually inside the image, and the image analysis follow through using that pen sharpening image could be mistaken sometimes. So be very careful with this tool. So next example, we'll talk about the texture analysis, and let's get right to that example. And I'm just gonna comment out so we can better see our code. Okay, so this example is using texture analysis. Texture is basically a way you can compute how different one pixel is changing in relative to the other pixels around it inside the image. It is used very often to identify different types of features such as trees versus grasses, or impervious surfaces that are oftentimes very smooth, and it doesn't have much texture to it, so it's easier to identify impervious surfaces using lower image texture values. And we'll show you in this example how this works out. So first, line 66 to line 61, this is very simply just importing the image, and we are going to display it down below. And in this example, we are not using Landsat image. I'm just using the NAPE image for you to see this example. On line 69, that is where the texture analysis starts. So first we start with a near infrared band. We select this M band, and as I'm highlighted there, that is the near infrared band inside the nape image. And then on line 72, that is where we are constructing a 3x3 grid that is a circle, actually. I'm sorry. A radius of 3 pixels of a circle, if you can imagine, and laid it on top of every single pixel. And within those grid, we are comparing the center pixel with the pixels all around it to get a value of how different within that circle the different pixel values are. And on line 73 is actually we construct this circle of analysis of radius 3, and we apply this by using that circle on line 75. And we are, in this case, using this function called entropy. And entropy function basically, as I mentioned before, looks within each of these circles and compute how different the values are within the circles. And those values of how different the pixels are gets assigned back into that pixel. And then we display a brand new image on line 78. And this image we are displaying is called entropy, which is what I'm highlighting here. And this image contains how the neighborhood pixel values are different from the pixel we are interested in. So why don't we run this so it's better for me to explain this concept. So we hit run, and now you'll be seeing a bunch of different colors, as you can see on the screen here. So the first image layer I will show you, as you can see, that's the input image. And this is what you are looking at. And as you can see on the screen, it's very clearly the nape image, and it has a 1 meter pixel size. So it's very detailed there. And if we just zoom out so we can have a better comparison later on. So as you can see, let me just look at some areas so we can better identify them. As you can see, the carrier dome stands out very well. So hypothetically, we should be looking at a texture of very low in this region. So when we turn on the entropy layer, as we turning that on through checking that box, and you'll be able to see there are areas that has a different color from the rest of the fuzzy reddish color, as you can see on the screen there. And this simply means in this region on top of the carrier dome, the texture is very different from the area around it. And the reason being that is because the carrier dome has a very smooth surface, and the pixel values are all the same around it. And then that difference of the neighborhood entropy values shows us the carrier dome is a smooth surface. And if we look at other features, for example, grassy areas such as a park. So for example, there's a park right here. And if we just zoom in here, you can see the grass area are very smooth texture, if you will. And then the forest area around it because of the canopy, it is very not a smooth surface, and the values should be very different. And when we turn on the entropy layer, you can see that difference very, very, very clearly in the zoomed in version, as you can see on the screen there. And so this is a very useful tool to identify features in addition to the other tools we just talked about, the edge detection and pen sharpening. Hopefully these can be very useful tools for you to conduct image analysis. And in the next segment, we'll talk about image interpretations, and we'll be begin talking about how to do different analysis such as spectral mixture analysis or the image time series analysis, and hope to see you there. Thank you.